This is a typical find the shortest distance type question. We're given a point, 1, -1, and 3, and the equation of a line for x, y, z. It's parameterized, and what we want to do is find the q on the line that's closest to p, and then the distance between them. So we can do this one just using projections, because it's kind of the theme of this section. There's lots of ways that we can do it, but for now we're going to use those projections. So just sort of an idea of what's going on. Let's say we've got our line here. And so we have this point P that's not on the line at 1, -1, and 3. And we want to find the shortest distance somehow. So it should meet this orthogonally. So it should be somehow, yeah, perpendicular to that line. And so the way we can do this with projections is, first of all, just find an arbitrary point that is on the line. So a really easy one here we can get by doing t = 0 for the equation of the line. And that's going to give me a q, an r, because q is reserved for something else. So my r point, I'm going to get 1, 0, and -1. And then that is going to generate a line here. Well, it should be straight, but it doesn't look great. So this is going to give me a line from R to P. And so this line is the one that's described up above, which, again, we can rewrite this in the separated form, which would be 1, 0, -1 plus t, 3, 1, 4, so that the direction vector of that is the 3, 1, 4. So I'll call that my direction vector. V is 3, 1, 4. And so then what we're going to want to do is basically find the projection of that RP onto the direction vector V, because it's going to find this point Q for us right here. So this is the projection of RP onto V, and that is how we find Q. So we just basically are going to draw this triangle, and that does most of the work for us. So I'm going to find that projection, which is essentially, yeah, that'll give me RQ. They're the same thing. So RQ is the projection of RP onto the direction vector V. So that'll be RP dotted with V over V dotted with V, and then going along V. So my RP, I can calculate that one. I'll just do that on the side here. So RP, I know my P is 1, -1, 3, so 1 - 1, -1 - 0, and 3 - 1. So I should have this 0, -1, and 4 vector for RP. So I can plug that one in. 0, -1, and 4. And my V direction vector is 3, 1, 4. And that's going to be over 3, 1, 4 dotted with itself. And then along 3, 1, 4. And so when we do those dot products, we end up getting 15 over 26. 3, 1, 4. So in other words, 45 over 26, 15 over 26, and 60 over 26. And there's no point in reducing those fractions. Yeah, so we're going to just leave it like that. And so now, given that I know where R is, and I know the vector R to Q, I can now get Q. So Q is going to be, that's not a vector, that's just a point, sorry. Yeah, it's basically going to be R plus how we get from R to Q. So if R is at 1, 0, -1, and I'm kind of abusing notation here by using a vector for R, but it's just kind of going to organize it nicely for us so that I can see the coordinates better. And then my R to Q, 45 over 26, 15 over 26, and 60 over 26. And, just be careful with your fractions, but we should be able to calculate all of these to give us 71 over 26, 15 over 26, and that should be 34 over 26 when we add those together. So that's where the Q is. That does answer the first question. That's part of it. I found Q. And now to find the distance that I need to solve for this question. So that distance is going to be the length of P to Q. So yeah, we just need to find that. So my distance is the length PQ. Make sure I put a vector over that for correct notation. And so yes, we have to actually just find PQ or QP, or it doesn't really matter what order you write it in, because we have the 2 points. So it'll be, let's see, P is going to be 1 minus the 71 over 26. I'll just do it the other way around. So 71 over 26, yeah, Q minus 1, and then 15 over 26 minus negative 1, so plus 1, and then the 34 over 26 minus 3. And that vector is going to be, I've obviously got this worked out beforehand. I'm not doing this in my head. 45 over 26 should be 41 over 26, and negative 44 over 26. And we can clean up this distance calculation quite a bit. Notice that we can actually factor out that over 26 in here. So I can take out that over 26 and write 41 and negative 44. And then I'm allowed to actually just take that out of the length calculation. So now I can just get some nice, more manageable numbers. And I'll calculate my distance by just doing the sum of the squares, which I'm not going to write out, but if you add them all together, 45 squared plus 41 squared plus 44 squared, we get 5642. And that is the distance, the shortest distance.